Many of you have probably already heard of Flux. I've given a number of talks about it. This talk really isn't about an introduction to Flux, but it's about why we're doing it. And I've tried to explain this before. I'm going to try and take another stab at it this time. Explain some of the goals, talk about how it's evolved over time, basically over the course of the last year and a half. So before we dive in, I'll define what it is for people who don't know. Flux is a new open source, MIT licensed scripting and query language that we're developing at InfluxDB. Specifically, it includes a query planner. It includes a query optimizer. It's a Turing-complete language with a virtual machine and a query engine. There's multi-language support in the engine by design and multi-data source support. And I'll talk about these a little bit. And ultimately, it's delivered in a few different form factors. As something that's embedded inside InfluxDB, as a command line interpreter, so you can run Flux scripts completely outside of the database, as a REPL that you can run, or as a Go library that you can bring into your own projects. So really quickly, this is what a basic query looks like. We're getting the data from the telegraph bucket for the last hour, for the CPU measurement, and the usage system field. You can see we have comments, we have named arguments, we have string literals. We're calling things buckets, not databases. We have duration literals, time literals. We have this funky pipe forward operator, which basically pipes the results from the last function that was called into the next function after it. We have anonymous functions. And this here is actually a predicate function that specifies basically matchers for looking up time series in Influx. All right, that's the basic intro. Now I'm going to talk about the journey that we've taken here with Flux, the language. Now, at GrafanaCon last year, at the beginning of March, I gave a talk, and the talk was the design of IFQL, the new Influx functional query language. So as you can see, my thinking at the time was that the language was essentially a query language for the next version of InfluxDB, which is completely different than what it is today, right? I thought, OK, it's a new query language for InfluxDB. Ideally, we're going to give people some functionality that they didn't have before in our old language. There are feature requests that we've had for years that we wanted to address that we couldn't. So we thought, we'll do a new language and enable those things. But then I thought, we actually want to do more than just query data. We want to be able to process it. We want to do monitoring and alerting on it. We want to do ETL tasks. So really what we want is we want a scripting language in combination with a query language. And then I thought, well, why tie this specifically to InfluxDB? People actually want to join data from other data sources in real time with their time series queries. And ideally, we'd enable that, and we'd enable them to do that within Flux. So basically, once we decided it wasn't going to be specific to InfluxDB, we had to come up with a new name, right? It's no longer just a query language. It's no longer InfluxDB. So in June of last year, we renamed it to Flux. We moved it into its own repository on GitHub so that people could use it completely in isolation from the database itself. And more importantly, we MIT licensed it. Before we were going with the AGPL, this was during a phase where I was debating my viewpoints about open source licenses and stuff like that, fairly firmly in the MIT camp or Apache 2 for my open source work now. So that's what it is, MIT without restriction. And then after that, I wrote this blog post, why we were building Flux. Now, this blog post was basically a lot of words about what we were doing and what we were trying to accomplish. And I had very little actual Flux code in it. This is basically the only thing I had in there, which is we're taking data from a telegraph database. We're calculating an exponential moving average. And in the post, I had people ask me questions about why we're doing it, and I had people ask, how does it compare to SQL? Why aren't you using Lua or JavaScript or something like that? So basically, it's a new language, and I'm thinking, OK, I need to get this thing a lot of attention. How do I get the people on the Orange site to pay attention to me and talk about this thing? I thought, OK, why don't I say something completely ridiculous about SQL? That's a good way to do it. This will really get everybody activated and get them talking about this thing, right? Of course. Well, they found us, and it got upvoted to the front page of Hacker News. And the thing is, like, whenever you get to the front page of Hacker News with something that you wrote, either software or words, you kind of have to prepare yourself. You have to go in and say, OK, I'm going to have a thick skin about this whole thing. I'm just going to like brush it off. So I picked out some choice quotes. This is somebody who does not like the design of the language. Thank you, Tyler L. Yeah, great, Perl. So somebody actually took affront to that. He's like, Tyler L's insulting Perl. Ouch. This is a long one, but basically the end result of it, I love the last few words, which is basically, you will accomplish nothing great. That hurts. This one, so basically this is our science project because every programmer dreams about making a programming language. We all did it in college, right? You took PLT. This one's great. Just attack the name. So, you know, I look at all of that and I think, OK, maybe I can brush it off. But then also within the thread, there are legitimate comments. There are comments that are constructive. And I thought this one was actually on point. It was a bad idea to focus on Flux versus SQL. And the thing is, like, the reason why I did that is because people asked me, and I'm like, OK, I should probably do that. I should talk about it. And the thing is, like, somehow, no matter how many times I learn this lesson, people have to remind me again and again, don't be a jerk. So basically what I want to do is I want to talk about why I'm excited about what we're building, and not try to get drawn into why is it better than X or Y. Because ultimately, open source is not a zero-sum game. Flux can be successful, and SQL will continue to be successful. There's no need to defend SQL. Its legacy is secure. So really, like, what I want to do is I want to rethink this quote. And this quote doesn't mean like SQL is bad. Actually, in the blog post, I said SQL is great. So let's just remove this part of the quote. I don't want to live in a world where. That's true. I have that feeling. I don't want to live in a world where we can't try something new. SQL is great, but I do want to try something new. And I was talking to like one of my engineers, and he also was saying like, don't try to do the SQL comparison thing, dude. Like, it's a bad idea. Really, what you're trying to do is we're trying to create a fourth generation language. And I hadn't actually heard this phrase before. It's shortly referred to as 4GL. So the truth is we don't want to be better than SQL. We want to be this. So Wikipedia, and I'll just read this, defines a fourth generation language. While the definition of 4GL has changed over time, it can be typified by operating more with large collections of information at once rather than focusing on just bits and bytes. Languages claimed to be 4GL may include support for database management, report generation, mathematical optimization, GUI development, or web development. So that actually, to me, that sounds like exactly what we're trying to do with Flux. We're trying to come up with a language that makes it easier to work with time series data, with large collections of data. And some people who talk about 4GL languages say that domain-specific languages are actually an example of 4GL. So if I accept that, and I say, OK, domain-specific languages are that, and we want a language that's Turing complete, then why don't we just do JavaScript, right? There are tons of DSLs that are built on top of JavaScript, right? It's very successful. But the thing is, like, if we did JavaScript, we'd have to pull in an entire implementation. We'd have to deal with all of that code and all of the baggage that comes with it. And ultimately, we don't want all of JavaScript, right? We want the good parts, or we want a subset. But the thing is, if we're going to take a subset of JavaScript, then it's no longer JavaScript, and we're in the boat again where we're just talking about a new language anyway. So that's part of the reason why we didn't just pick up JavaScript and use that. So ideally, Flux should support language services that drive graphical user interfaces. And we haven't dove into this that much yet, but it's part of like the longer term vision that we have. many data sources, right? InfluxDB, files in any formats, CSV, JSON, XML if you hate yourself, S3, files from S3, Postgres, MySQL, Redis, MongoDB, basically any third-party API where you can grab data, we want to have a connector in Flux to do so. And ideally, what we want to do is we want to optimize for each one of these. As I mentioned, there's a query planner and an optimizer, and we want those to take advantage of each data source's unique capabilities, right? A MySQL database has far more functionality and power than, say, a CSV file on S3. Cross-compilation is a big goal. So Flux is one example of a language that the engine can process. But we've already started creating an InfluxQL to Flux AST transpiler, right? Because we have to support InfluxQL in the new version. So we want people to come with InfluxQL if that's what they like, Flux if they want that, tick script we're going to have to do. And very recently, we started looking at a proof of concept to transpile PromQL into the Flux AST. So we've actually contracted with Julius Volz, one of the creators of Prometheus, to start looking into this. And he has like a basic query that worked. They just got to work on like Sunday. And basically, like he used some of the functionality in Flux that doesn't exist at all in the InfluxQL engine. So what that means also is that the Flux AST is going to be part of the public-facing API. So once we lock this down, once we create the 1.0 version of Flux, people can build language parsers that parse those languages into a Flux AST, which can then be executed by the Flux engine. And speaking of the engine, it's designed to be distributed. We want it to be able to query from multiple data sources, push down the computation that it can to each of those data sources' capabilities, and then combine the results in memory in the engine itself. Now, under the covers, the Flux engine views all data basically as tables. It uses Apache Arrow, which is an in-memory columnar data format for basically computing things really fast. So last year, we started a Go implementation of Arrow, and we contributed this to the ASF. So they took this, and it's now part of the Apache Arrow project. And we're seeing more and more people contribute to it, which is great. So the thing about Flux is, to the Flux engine, it has nothing to do with the InfluxDB like data model. It sees tables everywhere, just like Arrow does. This means there's no limitations on what you can do with your data, whether it's a measurement, a tag, a field, or a value. It also means maybe remember that PromQL transpiler? Someday soon, you may be able to query your CSV files with PromQL. So we can do things like sorting by any sort of column. We can group by anything. Like I said, we can do math across measurements. We can do anything we want. So moving a bit beyond that, moving to the 4GL part of this. The beyond queries. What's beyond just basic queries? So in InfluxDB 2, we have this concept of tasks. These are basically just background jobs that run either as streaming or batch jobs, right, like capacitor. And they take Flux scripts and they compute them in the background. That's this part right here. So we added this syntax to the Flux language. As you can see, it has like this cron scheduling syntax. We also support something more basic where you can just say run once an hour or whatever. We support packages and imports. So basically, like this script, the details of the script aren't really important. What's important is the different features that we have in here that we're trying to squeeze into the language. Map for looping over records. You can change the records. You can modify the schema. You can change the values, the tags, all of this in real time. There's string interpolation in the language. We can ship data elsewhere. I said I wanted it to be multi-data source. I also want it to be multi-data sync. The idea behind Flux is, right, one mode of querying is interactive querying where you return results for the user. Another mode is you compute something and you pipe it back into InfluxDB, or you pipe it out to Kafka, or you pipe an alert to Slack or to SMTP. So we want to be able to support that. Loading secrets, this is just basically like a function that's built into the language. You'll be able to connect it to secret stores like Vault, so you can pull that into your Flux script dynamically, and it should be super easy. Another thing is testing. So we want users to be able to develop a Flux script on their laptop and test it in airplane mode if they had actually used the CLI to basically query an Influx server to pull down a test data set, show what their expected result is, and use the CLI to actually run a complete Flux script through a test. So where are we with the project? Still pretty early days, right? I mean, we've been working on it for about a year and a half, but what I tell my people internally, like the sequencing of how we're building this thing, well, first, make it powerful. After we've made it powerful, we should make it easy to use. And that's always a key for us. We want things to be easy to use. We want everybody to be able to pick it up. And ultimately, after that, we want to make it fast. So right now, we're still in the make it powerful stage. We haven't even started on the make it easy to use phase. When we make it easy to use, we'll probably add syntactic sugar to make it so that you can issue queries in a more terse format rather than this, pipe forwarding all these functions and stuff like that. We'll add built-in functions that'll get more done out of the box and all that kind of stuff. So in InfluxDB 1.7, there's a preview release of Flux that you can enable if you actually turn the configuration on. The alpha of InfluxDB 2.0 shipped about 4 weeks ago. And it is in that. That's the fastest and easiest way to get running with Flux. So if you go to the influxdata.com/download page, there's a prompt, and you can just follow that. So to recap, Flux is a new MIT licensed scripting and query language that we're developing. It's multi-data source, so it's not just InfluxDB. It's multi-data sync. It's Turing complete, so you can do more than just query a database. You can do all sorts of other computation. It's liberally licensed, and like I said, not tied to InfluxDB. Ultimately, we want Flux as a community and as a project to get bigger than InfluxDB. We want more contributors in Flux, and we want more people using it. If other people pick it up and they embed it in their projects, that's great. That's the kind of adoption that we want to drive with it. Thank you.
So we have quite a few questions. So first up, will Flux allow joins across different types of data sources? Example, joining SQL within Flux.
Yes.
Great.
So right now, if you look, so there's like in the Flux repo, there's standard library, and within there, so the packages that are laid out are basically what we're laying out for the standard library right now. And there's like this hacky SQL connector there that I think will allow you to pull data from a Postgres database. And you can actually use that with the join to join like reference data with time series data on the fly. That works today.
That's really awesome. I guess the next question I think is the same. So foresee having Flux Grafana data source capable of querying multiple databases or data sources in the same graph.
That's a David question.
Yeah, that is a David question. Maybe David will cover it. Yeah, I guess that's interesting. I mean, so for Grafana, I guess that really comes down to the type of query that we use. Obviously, you talk about Flux having a transpiler down to a different language. Whether or not Flux natively will enable you to embed those other queries. Yeah.
So I mean, like long term, the ideal scenario is like, if you wanted to, you could access your SQL data through the Flux builder in Grafana. The truth is, like, the initial versions of those connectors are basically going to be super basic, where it's going to be like, import SQL, SQL.from, and you're just going to pass it a raw SQL query, right? Which is not, from a UI perspective, that's not what you want, right? You want the UI driving the actual building of the query. Ideally, as the connectors get more featureful, I would expect Flux, the language, to act almost like an ORM, where it's like if you're pulling from a SQL data source, it would take those Flux function calls later and use them to actually construct a SQL query on the fly that can be pushed down to the database. So once we get that dream, then maybe you would actually build say, queries for your Elasticsearch or your SQL Server in the Flux builder, but that's going to take time.
Yeah, there's definitely some syntactic sugar that I guess we could add in on the Grafana side as well to kind of have that work with synchronization between data source names on the Grafana side with what's in the back end.
Yeah.
Okay. So use case wise, where does Flux fit versus tick scripts in your platform? Is it a replacement?
Ultimately, it's a replacement. The idea with Flux is we wanted to combine the languages for either interactive query for dashboards or background processing and just have one language that's easy to work with and easier to debug. One of the biggest criticisms on TickScript, other than it looks completely alien and like nothing else, is that it's very, very hard to debug capacitor tick scripts, and that's something that we want to correct with Flux. We want to give debugging tools out of the box.
Great. So next question is, for the new language Flux, what about the activities of adaptation from the Grafana side? Will there be expected some kind of feature parity with InfluxQL? And I think we already have a data source plugin for Flux, right?
Yeah, so you already have a data source, and we are a customer of Grafana Labs. We pay Grafana Labs to hopefully continue to develop the Flux data source because we want Flux and actually InfluxQL to continue to be first-class citizens in Grafana. So
yeah, that's definitely the case. So I think there may even be a talk tomorrow, a little bit more detail on Flux and Grafana, so with the data source. So who was that? Jasmine. You should check that out. Here's a good question from Ryan. What will be the enterprise features of Flux?
Flux, the language, won't have enterprise features. We won't hold functionality out from the language. InfluxDB will continue to have an enterprise version. What that looks like for 2.0, we haven't completely nailed down. Basically, it will be at least as much stuff as in InfluxDB 1.x will continue to be open source in 2.0. Really, the question is, can we expand the footprint of stuff that we have in the open source to give more people more stuff for free? But from a Flux language perspective, there's nothing I can imagine that we would hold out for enterprise. We'll accept pull requests. We'll accept pull requests to integrate it with competitors of ours. We've done that with Telegraph, our data collector, because we wanted the community for Telegraph to not be limited to InfluxDB, and we're going to do the same for Flux.
Not even connectors? Will they any closed source connectors or?
I mean, if somebody wants us to make an SAP connector and they want to pay us for that, then maybe we'll keep that closed source. But for SAP.
All right. So yeah, and if you can afford SAP, that's fine. So a question from Jasmine: how long will InfluxDB 1x releases plan to be supported for?
So support for 1x releases is going to continue on for a very long time. I mean, we're going to cut so we just cut 1.7. We'll cut 1.8 later. 1.8 is tentatively the last planned 1.x release, but there will be bug fix releases for 1.x. And for our customers, we're contractually obligated to continue to support 1.x for years. And from 2.0's perspective, I'm giving a whole talk on 2.0 tomorrow morning, but from 2.0's perspective, there's basically a compatibility mode that you'll be able to turn on so that you can interact with the server as though it's an InfluxDB 1.x server.
Okay, and one last question from Ryan. So it looks like some high-level comparisons could be made to Apache Drill. Is that something that you've been involved in or had a look at, and anything you've learned from their success or missteps?
I've not been involved in it, no. Yeah, I'm not sure. I'm not I looked into Drill a long time ago, but I can't really. It did not serve as inspiration for Flux, really. I think inspiration for Flux was more driven by what's going, by pandas, by the tidyverse stuff in R, also by the function chaining syntax that you see in libraries like D3 or jQuery, right? Okay,
great. Well, thank you very much, Paul. I think let's give him a round of applause. Thank you.